guys, let's try this again. So today we're going to be solving design, add, and search words data structure. And yeah, to do this, you're going to basically use a try. I could create a try from scratch, but I guess we could just make the word dictionary itself a try. And then just work from there, I guess. So this is going to have self dot children, if I can spell, and that will be a set that'll take in characters, and we'll also have self that is word to just keep track of whether what we have is a word, and we can initialize that to false. And yeah, to add a word, now we're gonna set the current to self, and for each character in word, actually, yeah, for each character in word, we create a new one, which is equal to word dictionary, and if C not in dot children, we add it. So C dot children and C equal to what's that equal to? New. And then yeah, at the very end we just return we set cur equals to v, and yeah, that is probably, oh no, we have to set cur dot is word equals to false. Wait, true, sorry, because at the end we basically made a word. So to search, we're gonna start by returning DFS that takes in self, and yeah, 0. So this is the index of the word that we're gonna start from, and so we're just gonna do def DFS takes in a node, which is that's the try, and takes in 0. And how we're basically gonna navigate that is not supposed to be, that's supposed to be index, because we're gonna increment that every single one. And yeah, so to start off, we could just calculate the base case. So if I equals length word, that means we have the word, we can return if node dot is word. Otherwise, we want to basically set character equals to word I, so we just extract, we don't have to do that, but it'll make it easier to work with. And if C equals full stop, you want to basically be like for node, for every child of node, for child in node dot children dot, what else, values, I think. So for each child, we want to just check if I forgot how to use Python. If DFS, so I plus 1, and we have to pass in that child node in there. So if that is true, return true, and otherwise we just return false. So that's when we have a full stop, and if C equals actually if C in node dot children, so that means we basically have that word, and we can basically navigate to the next one. We just want to do DFS, return DFS. That takes in node children, and we'll pass in C and I plus 1, we have to increment by 1. And yeah, otherwise if we not also just return false if none of that is true, and that looks good to me. Now what did I do? Okay, the children. Is C not in Hard, which is this? It does have children, which. Oh. No way it's flagging that in there. It actually was. Wow. Alright. We should be able to submit it and it should work. Yeah, that is how to solve this one. Pretty much you have to just think about it on like a try. You add in a word, just add in letters to set, where the key is the character and the value is another world dictionary, or we could do this with a try. And then in the search, we use a DFS. So if it's a dot that we encounter, we basically loop through it. And if we basically have a character, we do DFS with children of that character. Not the children, the actual node of that character. Yeah, if you get what I mean. The actual node, and then we add I plus 1, and then we return false if that doesn't return true. And yeah, that's pretty much it.